1.8 million years ago, somewhere in East Africa, a tribe of hominins returned from a hunt empty-handed. They communicate to each other that the animals seem to be disappearing, and hunting for food is becoming more and more difficult as time passes. As the light fades and the darkness begins to creep in, they hear children's laughter. The children run into the camp, their hands full of bird eggs and insects, followed closely by the tribe's females and older members carrying fleshy leaves, fruits, nuts, roots, and tubers. This is enough to fuel the tribe for a day, but they know that this is not sustainable, and they will eventually have to move on to find more animals to hunt. They didn't know that they would be the first member of the human species to leave Africa and settle down in another part of the world. But for this night, this one night, the tribe can eat around the fire under a beautiful night sky and share that moment with each other as they live to see another day. This is the harsh life of Homo erectus in Africa 1.8 million years ago. Homo erectus had relatively elongated legs and shorter arms compared to the size of its torso. These features are considered adaptations to a life lived on the ground, indicating the loss of earlier tree climbing adaptations. They had the ability to walk and possibly run long distances, unlike Australopithecus, who had strong, powerful arms and curved toes designed for tree climbing. Although they could walk upright, they weren't suited for long distance running or walking. Homo erectus is the oldest known human to look like us. They paved the way for future members of our genus by being the first humans to migrate out of Africa, the first hunter-gatherers, and the first humans to control and use fire. Compared with earlier humans, Homo erectus had a larger brain case compared to the size of its face. Homo erectus' brain was 50% larger than its predecessor, Homo habilis, and it experienced the biggest drop in tooth size in human evolution. This points towards the idea that Homo erectus cooked their food, and there is even some evidence that points towards Homo erectus learning to control fire as early as 2 million years ago. We know that cooked food not only saves us energy and time from chewing and digesting, but actually makes it easier for our body to absorb its nutrients, meaning that we get more from cooked meat than raw. This could have given Homo erectus a large surplus of energy compared to other meat-eating animals, allowing their body to support and encourage the growth of a larger brain. Homo erectus lived from 2 million to 100,000 years ago, with some estimates suggesting that they died out 50,000 years ago, making it the longest reigning human species, and this had its effect. Late Homo erectus had a brain 50% larger than their earlier ancestors, despite them being the exact same species. For contrast, Homo sapiens appear in the fossil record 300,000 years ago, and their brain size is the exact same as ours today. It is not known what caused late Homo erectus to have a larger brain than earlier members of their species, but some scientists suggest that it grew larger as Homo erectus settled in new areas of the world, requiring larger brains to remember new animals, skills, and locations to survive. The most complete fossil of Homo erectus is known as the Turkana, a well-preserved skeleton dated to around 1.6 million years old. Estimates of the Turkana age at death range from 7 to 11 years old. These estimates are based on the maturity stage of the teeth or skeleton compared to that of Homo sapien or to chimpanzees. Although he died young, his bones show that he did not die from an attack by a predator because his nearly complete skeleton shows no damage from either predators or scavengers. Instead, his jaw shows that he had diseased gum, where a deciduous molar, one of his baby teeth, had been shed. An infection seems to have set in, and he probably died of blood poisoning. We know that Homo erectus began to migrate out of Africa roughly 2 million years ago, but why did they decide to leave? There are so many different interpretations and theories, but perhaps the most realistic and backed theory is the Sahara pump theory. This theory suggests that droughts in Africa led to starvation due to lack of vegetation and water, resulting in prey migrating into different directions. Flora and fauna previously widespread retreated northwards to the Atlas Mountains, southwards into West Africa, or eastwards into the Nile Valley, and then either southwards into the Ethiopian highlands and Kenya, or northeast into Asia. This separates populations of some of the species in the area with different climates, forcing them to adapt, leaving some populations of Homo erectus in Africa and others in the Middle East, where they made it as far as the Indonesian islands of Bali, which was separated from the eastern islands of Indonesia, New Guinea and Australia by a trench of deep water. Sumatra, Java and Bali were connected to Southeast Asia by land bridges created when the sea levels dropped during the Paleolithic ice ages. Homo erectus also made it to Morocco, Algeria, Georgia, China, and perhaps even Germany. The only European remains attributed to Homo erectus are skull fragments that were excavated in Germany. The fragments seem to be consistent with other Homo erectus skulls, but the results are far from conclusive. Homo heidelbergensis and Homo antecessor, which are found in Spain and other parts of Europe, are thought to have evolved directly from Homo erectus, pointing towards the fact that Homo erectus migrated in isolated waves in different directions. There is still lots of research to be done on this subject, and it's unlikely we'll ever know for sure, but one thing we can say is that Homo erectus was a widespread species that reached many parts of the world. Early Homo erectus had smaller, more primitive teeth, and thinner, less robust skulls compared to later specimens. The species also had a large face compared to modern humans. Like Neanderthals, their skull was long and low rather than rounded like our own, and their lower jaw lacked a chin. A prominent brow ridge was present over the eye socket. All archaic humans have a brow ridge, but Homo erectus had the biggest out of them all. Researchers have recently indicated that the brow ridge may have had a role in social signaling between archaic human individuals, enhancing friendly or aggressive facial expressions. They could have been a mark of dominance in early forms, but changed to convey a wide range of emotions. Next time you talk to someone, take a note of how their eyebrows move depending on what emotion they feel. Homo erectus was the first to use fire and sophisticated tools, called Acheulean tools. Homo erectus produced sophisticated stone axes and used sharp stone cleavers and finger-sized scrapers that they used to slice off chewable slices of meat. These tools gave Homo erectus access to large herbivores like elephants and wildebeests. Homo erectus made the first wooden spears and first wooden bowls. Using stone anvils and point pressure tools, Homo erectus was able to fashion larger tool heads and fine long blades sharpened on both sides. They made hunting tools with spear points for throwing and thrusting, and axe heads for chopping and dismembering carcasses. Perhaps they used cooperative skills in hunting to drive rhinos, elephants or mammoths over cliffs or into swamps, just as our species did thousands of years later. In 1980, Rick Potts, director of the National Museum of Natural History's Human Origins, and his team got to work excavating the southern Rift Valley in Kenya. What him and his team went on to discover there was nothing short of extraordinary. The team was digging in a region called Olasile in southern Kenya, an area filled with layers of sediment dating back 1.2 million years. The oldest stone tools discovered there are characteristic of what's called a Acheulean culture of the early Stone Age and consisted mostly of hand axes. You can learn more about Acheulean culture as well as other Stone Age tools in this video here. In addition to branch and carcass chopping, the axes were likely used to dig for water to drink or tubers to eat. The carcasses probably belonged to large animals like the giant ancestors of hippos, elephants and wild pigs that roamed the grasslands. But around 320,000 years ago, the ancient humans seem to have switched to an entirely new technology. The team found numerous smaller, flatter, sharper stone tools. Rick Potts said that we see a smaller technology, a more diverse series of stone tools. These tools were designed for specific purposes. Some were used as blades, some as scrapers, or some as spearheads. The new studies also show that 320,000 years ago, this technology was well established in the region, suggesting that our human ancestors likely started developing it even earlier. Rick Potts also said, "We see the ability to produce small triangular points that look like they were projectile points. They were tapered at the end, so that could have been put on the shaft of something that flew through the air." This points towards the fact that Homo erectus used spears for throwing and thrusting. This also further supports the fact that Homo erectus was the first human to shift from scavenging to hunting. An analysis of the fossilized animal bones found in the sediment show that people in that period were eating a range of mammals, including hares, rabbits, antelope, and even a couple of species of bird and fish. Homo erectus wasn't just picking up nearby stones to create their weapons. Earlier hand axes were made primarily from volcanic basalt, sourced within 2 to 2.5 miles of where these humans lived. The later weapons were made of stones like obsidian, which originated far from Oligocele. Rick Potts said, "That's black obsidian. That rare rock was being transported, brought in chunks from 15 to 30 miles away. We have a couple of rocks that were brought from up to 55 miles away. These distances are far greater than what modern hunter-gatherers travel over the course of a year. They weren't just travelling long distances and chipping rocks as they go. If they did that, then there would have just been small chips of obsidian left at the archaeological sites that we dig. Instead, we see large pieces of raw material coming in. The rocks were shaped at Oligocele itself." They think that this kind of exchange of raw materials is a telltale sign of trade between different groups of people. He says that in the Middle Stone Age, we begin to see early stages of social networks, of being aware of another group and exchanging rocks over long distances. Potts and his colleagues also find evidence of exchange of brightly coloured red and black rocks that were drilled into, possibly to extract pigment. This is the earliest evidence of the extraction of pigments. It's also evidence of a complex culture where Erectus probably used pigment symbolically, perhaps to paint themselves, their hides, or weapons. In 2000, Japanese archaeologists uncovered the remains of what is believed to be the world's oldest artificial structure on a hillside at Chichibu, north of Tokyo. The shelter would have been built by humans, but it's not clear who. It is thought that Homo erectus lived in the area. The site was dated to 2.5 million years ago, and it consists of what appears to be 10 post holes forming 2 irregular pentagons, which may be the remains of 2 huts. 30 stone tools were also found scattered around the site, and as we know, Homo erectus was very capable of making stone tools. Ancient humans thought to be Homo erectus that lived 350,000 years ago near present-day Bilzenslegen, East Germany, constructed shelters similar to those of Bushmen in South Africa. Circular bone and stone foundations were discovered for 3 huts between 9 and 13 feet across. In the middle of one circle, archaeologists found an elephant tusk, which they speculated was the centre post. So if Homo erectus was able to build shelter, hunt large game, and possibly even trade with neighbouring tribes, then surely they had some sort of language, an advanced social structure. Evidence that points towards an established social structure is found in 4 sites outside Illorat, Kenya, where 97 footprints dated to 1.5 million years ago were likely left by a group of at least 20 individuals. One of these trackways, based on the size of the footprints, may have been an entirely male group, which could indicate that they were a specialised task group, such as a hunting party or foraging party, or maybe even border control. If correct, this would indicate sexual diversion of labour, which distinguishes human societies from those of other great apes and social mammalian carnivores. In modern hunter-gatherer societies who target large prey, typically male parties are dispatched to bring down these high-risk animals, and due to the low success rate, female parties focus more on predictable foods. Based on modern-day savanna, chimp and baboon group composition and behaviour, Homo erectus may have lived in large, multi-male groups in order to defend against large savanna predators in open and exposed environments. However, dispersal patterns indicate that Homo erectus generally avoided areas with high carnivore density. It is possible that male and male bonding and male and female friendships were important social aspects. The Tucana boy was diagnosed with juvenile spinal disc herniation, and because this specimen was still growing, this caused some scoliosis. These usually cause recurrent lower back pain and likely restricted Tucana boy in walking, bending over, and other daily activities. Despite this, he appears to have survived into adolescence, which points towards advanced group care, further pointing towards that Homo erectus was highly sociable. But the question we're all probably asking is, could Homo erectus actually talk? Neurologically, all humans have similarly configured brains, and the Broca's and Wernicke's areas of the brain in charge of sentence formulation and speech production, of Homo erectus were comparable to those of modern humans. However, this is not indicative of anything in terms of speech capability, as even large chimpanzees can have similarly expanded Broca's areas, and it's unclear if these served as language centres in archaic humans. Evidence that Erectus had language comes from their settlements, their art, their symbols, their sailing ability, and their tools. Erectus settlements are found throughout most of the Old World. Erectus settlements show evidence of culture, values, knowledge, structures, and socialization. This evidence is important because all these elements enhance each other. Evidence from the Erectus settlement studied in Israel suggests not only that Erectus controlled fire, but that their settlements were planned. One area was used for plant food processing, another for animal material processing, and yet another for communal life. Erectus, incredibly, also made seacraft. Sea travel is the only way to explain the island settlements of Indonesia. It wasn't accessible to Erectus, except by crossing open ocean. These island cultural sites demonstrate that Erectus could construct seaworthy crafts capable of carrying 20 people or more. According to most archaeologists, 20 individuals would have been the minimum required to find the settlements discovered. Erectus seems to have the capability to make art, as seen in the 250,000 years old Venus of Berekut ram, which is a pebble carved into what seems to resemble a female body. However, this is just an interpretation, and some people even say they can see it resembling other things, like a head or even a penguin. Regardless, we know Homo erectus made some form of art, even if it was very basic, as we found seashells with patterns carved into them. We also know that Homo erectus dug up rock pigments, suggesting, in my opinion, that they may have used it to draw on themselves or even perhaps on rocks and walls. We simply don't have enough evidence to confirm or deny this, but who knows what has been lost to the environment and what has failed to preserve. To build and operate boats, Erectus needed to talk about what materials to collect, where to collect it, and how to put the materials together, just as we ourselves would need to talk about in order to build a raft. In addition to the assembly of the raft, the planning for the trip as a whole and the reasoning for undertaking it would have all required language. Although we can't say for sure, I think it's likely that Homo erectus had some sort of language. They definitely didn't have language as advanced as we do today, and they may have even been incapable of making the same sounds as us. But I don't think it's outrageous to suggest that they possessed some sort of early building blocks of language, like basic sign language and gestures, that eventually evolved into what we know today. It's thought that Homo erectus possessed the movement in its shoulders that would allow it to throw at high speeds. Evidence that I mentioned earlier in the video also suggests that Homo erectus may have been using spears to hunt. Homo erectus sites frequently are associated with the assemblages of medium to large sized game, namely elephants, rhinos, hippos, and boars. Homo erectus would have had considerable leftovers, potentially pointing towards food sharing or long-term food preservation, such as drying. It is possible that they grew to become quite dependent on large animal meat, and the disappearance of Homo erectus from the Levant is correlated with the local extinction of the straight-tusked elephant. Their diet likely varied, widely depending upon location. For example, at a site in Israel, the inhabitants gathered and ate 55 different types of fruits, vegetables, seeds, nuts, and tubers, and it appears that they used fire to roast certain plant materials that would otherwise be inedible. They also consumed amphibians, reptiles, birds, aquatic and terrestrial invertebrates, in addition to the usual large creatures such as elephants and fallow deer. A study published in the Journal of Human Evolution, volume 138, January 2020, has concluded that Homo erectus was entirely capable of using persistence hunting techniques to hunt large prey. Persistence hunting is when a group of humans wear down a prey animal in long-distance pursuits. Humans have an ability that would allow them to run for long periods of time, and that is sweating. A few other animals have the ability to sweat, but not as effectively as humans. The evaporation of sweat is the body's most effective method of offloading heat if you're working hard, especially in hot, dry conditions. What's interesting is that using sweat as a primary method of heat loss is relatively unique to humans. Very few mammals perspire at all, and those that do all sweat quite a lot less than humans. Per unit of body surface area, we sweat about 2 times as much as camels, and about 5 times as much as horses, who are a couple of the next most proficient sweaters. Many mammals primarily lose heat through panting. This has the advantage of conserving fluid and salt, but is less effective than the evaporation of sweat when the external environment is very hot. It's widely believed we developed our ability to sweat due to having evolved on the hot, dry plains of the African savanna. Humans don't have a very impressive top speed when compared to other animals like antelopes and onyx. So, to successfully hunt these prey animals down, our ancestors needed to find ways to catch them that did not involve simply outpacing them. But surely sweating so much would mean that we would have to stop for water, right? Well, going back to the study published in volume 138 of the Journal of Human Evolution, our results suggest that dehydration would not limit persistence hunting in Homo erectus. In our simulations, Homo erectus could hunt between 5 hours and 32 minutes and 5 hours and 40 minutes with no drinking before reaching the dehydration limit. The longest reported successful persistence kudu hunt by modern hunter-gatherers took 5 hours, at which time Homo erectus would lose about 9% of body mass. Such a degree of dehydration is not life-threatening for humans and other primates. In ambient conditions characteristic of persistence hunting in the modern Kalahari, which we argue is the conservative model for early Pleistocene East Africa, Homo erectus would reach a dehydration limit of 10% body mass loss in 5.5 to 5.7 hours. As such, Homo erectus would be able to accomplish all reported successful persistent hunts of large prey by modern humans, as the longest of these took 5 hours. So we know they were able to run for very long distances, but how would they actually injure or kill the prey? As we covered earlier in the video, it is likely that Homo erectus used spears. Due to how long Homo erectus survived for, their weapons would have varied massively. There would obviously be a difference between weapons made 2 million years ago and weapons made 200,000 years ago. As we see with the obsidian tools and smaller and sharper stone points uncovered in the Southern Rift Valley in Kenya, and how they vary to the older one tools made by Homo erectus 2 million years ago. The oldest known spears are the Schunningen spears, which date to roughly 400,000 years ago and were likely made by Neanderthals. I covered the Schunningen spears in this video here. But these spears were preserved by sheer luck, and it's very rare that we find anything made of wood that has been preserved. In my opinion, if Homo erectus was able to manipulate stone into sharp hand axes, then I think they were more than capable of at least sharpening sticks into points. There is obviously a lot of work that still needs to be done, and so much more to discover about how Homo erectus lived. We know that Homo erectus was smart, successful, communicated with each other, and had the ability to plan even months in advance. So how did they die out? Researchers indicate that Homo erectus likely went extinct due to climate change. Homo erectus was found with a collection of animal fossils that lived in open woodland environments, similar to the environment in Africa where it evolved. The environment at Ndong changed, and the open woodland was replaced by rainforest. No erectus fossils are found after the environment changed, so erectus likely was unable to adapt to this new rainforest environment. Surviving populations elsewhere gave rise to us, Neanderthals, and Denisovans, but we don't know if they were the last common ancestor. The youngest fossils of Homo erectus we have found are 108,000 years old, which tells us that we probably didn't meet Homo erectus, as we didn't leave Africa until 18,000 years later. Homo erectus is unmistakably human. When we go to the zoo today, we often relate to primates like chimps and gorillas, especially when they are playing with each other. Just imagine if we could go back in time and see an erectus tribe laughing, eating, and maybe even talking around a fire. In today's world, we are so disconnected with our past, and we don't seem to appreciate the story of our ancestors. With this series, I aim to bridge the gap between us and our ancestors, so we can appreciate and learn from them. Thanks for watching today's video. If you enjoyed and wish to see more, then please consider subscribing. There's a lot more content to come over the following year, so if you have any suggestions, then please leave a comment below. Thank you.